Welcome to my, hello everyone. Welcome to my virtual presentation for the OCP Global Summit. My name is Richard Hanley and I'm a software engineer at Google. And I'm here to talk to you about managing componentized servers using Redfish. And when I think about, I had a little bit of trouble coming up with a title for this talk because this is going to be a conceptual talk that kind of centers around a core question that I've heard a lot in Google, and I'm sure has been asked a lot throughout OCP, and that is, what is a machine? We're in the business of managing machines, and what exactly is it? Historically we view it as a CPU with RAM, disk, and that kind of definition has been challenged a little bit because the hardware is getting so much more specialized and complex. It's relatively easy to create custom hardware accelerators. There's a trend towards having offload cards and extra storage trays. The industry trend towards disaggregated hardware is another kind of challenge to this abstraction. So when we think of a machine, the machine is fundamentally an abstraction. And whenever I think about abstractions, I tend to get into the meat of the word. So the word machine is derived from machina in Latin. And machina is a device, contrivance, or instrument for executing a plan. This is where you hear the term deus ex machina or machinations. And I find that very useful to kind of like focus a discussion, but I also really like the definition that physics uses, which is an object used to produce work. So when we think about from management perspective, a machine is a single atomic unit to produce work or computations. And they're generally installed and serviced as a single unit. And the individual components don't make sense on their own. It's a storage tray or a memory bank doesn't really do anything unless there's also a CPU in front of it. And the actual physical topology of a machine can change a lot. Sometimes there are multiple ones on a same tray. They could be spread across several trays, or in the case of disaggregated hardware, there might be some sort of rack level fabric. And that last point, I really want you to kind of put that in the stack and in your mind, because I think it's important to separate out the physical hardware for a machine versus the machine as a logical abstraction. And as a motivating example, let's take a look at this extremely complicated machine being used to, we'll say, process large amounts of data with and serve it out. Think of like complex machine learning or video encoding or graphics types of work. And in this machine, you've got like four sockets, with on the north bridge, a custom accelerator, and there's offload cards for the data plane that have two CPUs on their own. So now those four sockets on the main machine can be focused directly on the core task, and you've kind of offloaded some of the other stuff. The storage tray has a database accelerator. And thinking about this machine, a machine in this complexity is hard to do on its own. It really helps to be able to modularize these machines. And one way you can modularize it is by the card and the tray. The storage tray is obviously a module. You might plug this into any number of different motherboards. And the offload card is another example of this. And the point here is that everything here has a BMC, and BMCs are getting cheaper, they're getting more powerful, they're getting more ubiquitous. And so rather than thinking about a single management controller, we can start carving this machine up into little independent modules, each with their own BMC, and then we kind of aggregate these various domains into a single logical construct that we can then call a machine. And what would this kind of domain view of a machine look like? Well, it kind of depends on where you're doing your aggregation. One obvious thing is you can do in-band aggregation, where the host kind of works and aggregates the various different BMCs. But there's some security and reliability issues with kind of having the host in that. So there's an industry trend towards out-of-band aggregation. And BMCs, as I mentioned, are getting a lot more powerful. So this kind of aggregation could be done on a master BMC that's connected to the other modular BMCs. Another kind of way to think about this is, could all be done through some remote service in another off the machine. And in that case, you have to start worrying about latencies, and you have to start worrying about the security is more important, and network topology. And one important thing here is that if every BMC is running Redfish, there actually isn't as much difficulty here. The differences here are really just a question of where does a web server live. So you don't need to have a physical view. You don't have to physically change your topology to move the aggregator in different places. But that might not be a safe assumption in the real world. There are plenty of existing offload cards that might not support Redfish, or they might not support having a full network stack connected. They might be through some sideband PCIe channels on SM bus or LPC. Basically, the assumption that all BMCs can run Redfish might be okay, but not this assumption that all BMCs have full network connectivity might not fly. So, if we're going to start aggregating multiple management controllers, we've got to get into the business of protocol drivers, where we're creating bridges between an HTTP Redfish and maybe a Redfish on PLDM over MCTP, or with an old IPMI management controller. And the other thing to keep in mind here is that these domains, Redfish is a web server, and a web server is far easier to fake or subvert than a physical SM bus connection where you need to get traces in. So these domains definitely need to be authenticated wherever possible. And authorization is a little interesting here, because you want all of your domains to have full control over be master of their own domain. And then the aggregator ends up being the place where that's the point of contact to the rest of the world. So the rest of the world needs to have, the aggregator needs to dole out authorization rules. And I think that working to get mutual TLS into Redfish is kind of like a first class thing, is something that we're going to be working on. I know that OpenBMC has a OEM version of this, and I think that would be a useful little improvement on this kind of architecture. So once we figure out this core use case and kind of this idea of aggregating to a single Redfish service, we get into the task of, well, what does a Redfish aggregator look like? And I think one way to think about that is to kind of go into this foundational view of Redfish and try to look at Redfish as data-driven as possible. And in some ways, Redfish really helps this, because they work very hard to separate the data model from the transport protocol. And when I look at Redfish, I kind of see it fundamentally as a graph where each node, also known as a resource, has certain fields. It has a schema. It has supported methods. It has ACLs. It also has a way of asynchronously sending events. It has tasks that can be running in the background that you can query status of. And resources can also create and delete other resources. And then we have resources connected along edges, and each edge has certain metadata or tags. And if we can take a Redfish service and deconstruct it into this graph of somewhat atomic resource nodes and edges, then the task of aggregation becomes functionally a data task, how you take two graphs and merge them together. And I think this helps kind of put together what an aggregator can do at this level of creating a logical construct around a machine. Obviously, we've just hinted at some tooling around creating protocol drivers. If there are BMCs that are using a slightly different protocol, well, you need to have profiles for how to unpack and repack data between the BMCs. But this concept of a stateless presentation layer through which we can build a Redfish surface, I think is really interesting, because if you looked at the previous graph here, you can construct this graph without really needing to know anything about the actual schema of the resources. So the aggregator can do meaningful work without actually knowing the data, the actual data that it's aggregating. And on the flip side, the aggregator is now being worked on a functional interface. So you are able to you're able to basically reduce the surface area that the aggregator needs to care about. And if in the future you wanted to support different protocols like Redfish over PLDM, you can. It gives you some flexibility to change the way that the Redfish service looks and feels without necessarily having to go in deeper into the aggregation layer. So I mentioned that this is this was a conceptual talk. I think when DMTF and the Redfish forum talk about aggregation, they tend to be thinking a lot about aggregating racks and aggregating data centers. But I think that aggregating within a machine is a different and also really interesting and useful problem. And this task of aggregating BMCs is another really interesting problem. So I've started talking about this in OpenBMC, and there's been some talk about aggregation in DMTF. I'd be interested to hear from OCP about any other interesting types of management controllers that could be aggregated in this form. And if you want to look up the mailing lists for OpenBMC, people are there. It's a very active community, and we'd definitely be interested in hearing what aggregation might mean to you. And because I could see this splitting up into 2 or 3 models, like a presentation layer and a aggregation layer and a protocol driver layer, I could very easily see this being split up into a few different modules that have much greater applicability than just a single aggregator. If you kind of have some ideas, but you don't necessarily want to talk, you can email me directly at rhanley@google.com. And I want to thank you all. You have a wonderful day, and I hope that you get a lot of value out of this summit. Thank you. Hello. I'm here live for questions if anyone's interested. I just got 2 questions. One from Roy Chua. Apologies if I mispronounced that. What are your thoughts around LFODIM initiative, HPE driven? I'm going to be quite honest. I do not know. I do not have a lot of context for that. I might be able to look into that offline. If you want to reach out to me later. I have a question from Taras. Is aggregation, in your point of view, is performed just using containment relation, or there can be are other more complex relations? I think that in aggregation there are a couple of things when it comes to relationships. I think that at its heart, I think aggregation requires a physical view of the machine, which Redfish tries to provide more of a functional view of the machine. So I can imagine some situations where you have where you have to do some more mix-in level, where you have some things aren't quite this points to this resource. You might have to do some merging. So I can't imagine that there would be some more complex relationships. And Roy Shua, should Redfish be focused on schema separate from aggregation methods? And there are some aspects of the actual, like from the Redfish protocol, that is primarily schema driven, and that aggregation is kind of just an implementation detail. But I also think that there is some forms of the schema which will help with aggregation. One example is, in the example of a storage tray that's on an offload tray for storage. That has some pieces of information that's being managed that go into /systems/storage. And the BMC on the motherboard is also going to be doing some other things on system/storage. So there is some interaction here on having some knowledge on this particular storage tray is tied in with this particular system and another thing. So I think that physical view of a machine affects things. Question from VJ: does aggregator need to be running in host BMC, or can it run in any independent machine which doesn't have a BMC? So I think that for a lot of what Google's thinking right now, we're kind of thinking of a push as BMCs have network connectivity. And so at least from my perspective, when a BMC has network connectivity, you don't actually need to worry about, like, the aggregator can exist off the machine. And I think that being able to support aggregation off the machine is the direction that I'm kind of pushing towards. Now, I do think that there would be some need for, and this is where you get into possibly there might be some hierarchies here, where a BMC might be aggregating for some other domains that can't connect to the network. I'm kind of interested to see how, if there is a safe assumption that all domains can be network accessible, then I think actually remote aggregation provides a lot of flexibility. Okay, from Jeff, Redfish support for aggregation services is in the next release. I will definitely be taking a look at that. All right, I think that I don't have any other questions. So, from Roy again. And would you see aggregation by domain, all storage under one umbrella, all NICs under another? I think when I'm saying domain, and I might be choosing the wrong word here, I'm thinking of the area, the things that are under control from a BMC. So a BMC kind of becomes master of its domain and is giving as much information as it can for that particular area. And I think that there might be other areas of computing that are using domain with a bit more specific terminology, and that I think I might have to choose a better word for that. So I definitely see some cross-functional things where you might have a BMC that's doing some storage work and some thermals and some BIOS things, and there's some crossover. It can get a little it can get a little messy in that regard. Previous from Mateusz, previous you mentioned Redfish over PLDM. Can you tell something more about that? Yes. So if you look at the trends with DMTF, DMTF has a Redfish working group, and they also have a group, the PMCI working group, which I actually can't remember what that stands for. But the PMCI working group is trying to get a protocols for intra-machine communication. So MCTP is kind of the foundation of that. And it's a way of basically having components talk over SM bus or PCI. And there is another layer on this, which is the PLDM. And PLDM is the platform level data model. And you can use that to handle like SM BIOS communication, and you can there's now a plugin for running Redfish over PLDM, and it's using a binary encoded JSON, and just kind of optimized for binary communication. And so now you have this concept of Redfish can exist in an HTTP environment as on an HTTP transport, but it can also use PLDM as another transport. Let's see here. Do I have any other? So I think that covers all of the things. So I want to thank you all, and have a wonderful day. And feel free to reach out on either email or on IRC or the OpenBMC mailing lists. I definitely pay attention to all three.